Welcome everyone. In this video I'm going to test two new Peltier coolers. I haven't tested these type of Peltier coolers before, so it's time to test them. And the reason why I want to test these and publish a video about it is because, first of all, there is a very little information available about these Peltier coolers. There is no datasheet, there is no proper information, no charts, nothing available on the internet. I spent a few hours on Google and I could not find anything meaningful. The only source of information was the data published by the sellers, and they were just some very generic data and just some pictures of the Peltier coolers and just some measurements. But yeah, there was no good indication of the real performance of these coolers. So I tried to make up that lack of information in this video and in my article on my website, and I will try to get out more information about these two coolers here. And what is special about these coolers is that according to their data published on the websites where I could find some small chunks of information about these things, is that their cold side can go to very low temperatures. We have two Peltier coolers here. Here we have the TEC2-19006. This is a 6 ampere unit, so I guess that's the last digit there. And the maximum temperature difference between the cold side and the hot side is about 80 degrees Celsius. So if the hot side, the real hot side inside the Peltier cooler, is kept at 30 degrees Celsius, then the cold side is supposed to be able to go down to minus 50 degrees Celsius. But of course the real hot side is always warmer, that we can measure here. And the cooling power of this is around 36 watts. And of course there is always a trade-off. If you have a large temperature gradient, then the cooling power is low. And if you want to have large cooling power, then the temperature difference between the two sides is lower. So the product of the cooling power and the temperature gradient is constant. That's how we could say the trade-off here. And as you can see here, this is rather special Peltier cooler because this is actually two coolers in one package. So you can see that we have two layers here, and that is the trick behind the very large temperature gradient, because what we have here is a stacked Peltier cooler, and the stacking was made in the factory. At this side we can see that small blob even here, and that is where the power goes from the bottom to the top Peltier cooler. And yeah, basically this is what we have. And according to one of the pictures that I found on Aliexpress, the cold side can go down to minus 31 degrees Celsius. And that is what I need. So it will be interesting to see this in action. And then we have this Heke Tech CL-C067 cooler. This is also a 6 ampere unit. And I could not find anything about its cooling power and so on, but what I could find is a few pictures, and that was also published on Aliexpress. And according to that published picture or set of pictures, the cold side was able to go down to minus 35.1 degrees Celsius, and there was another picture which showed minus 36 degrees Celsius. So we will see how this performs. But then an interesting thing is that this is just a single layer Peltier cooler. So it will be interesting to see how this can go down to such a low temperature if this is just a single layer. So it's not a stacked Peltier cooler. And since these two guys are like 6 ampere units, they are similar to the TEC2-19006 unit. But those kind of Peltier coolers can only go down to roughly minus 20, minus 23 degrees Celsius if the hot side is cooled like more or less well with, for example, a CPU cooler. but then these supposed to go 10 degrees lower than the TEC2-19006. So to test these units, I will have this regular CPU cooler, and this is just enough large, so I can cover the 4x4 centimeter Peltier coolers here perfectly. And of course I will apply some thermal paste and clamp down the Peltier cooler. And for clamping I made this nice little clamping tool. This goes on the top, and it's visible that there is a small edge here because it perfectly fits the Peltier cooler, as one can see. And then obviously the cold side will face upwards if I want to demonstrate properly. And then this is how it looks from the side, top. There will be a small chamber for the cold side, so it will be separated from the rest. I will use a small thing, a small acrylic plate, just to seal the cold side. And then obviously this will be clamped down, and the counter piece which will pull the clamp against the CPU cooler is this guy here. Again, a 3D printed piece. And I have the two bolts here and two winged nuts. And then the CPU cooler will be just cooled by a single 8 centimeter fan. It will pull the air and push the air through the lamella here, and basically that's all. So what I'm going to do is the following. I will assemble one of these Peltier coolers, and then I will progressively increase the current by 0.5 ampere step size, and at every 0.5 ampere I will measure the cold side temperature using a K-type thermocouple. And then I will create these charts to see what is the voltage, what is the current, and what is the cold side temperature. And then we can see how the two Peltier coolers behave. So I will assemble the first test system, and then I will explain a bit more information to you, and then I will start the testing. So now the test bench is done. So here you can see the sealed volume, and then that also means that there is basically no heat transferred to the cold side. And here I want to, let's say, explain a huge misunderstanding, because I see a lot of videos on Peltier coolers and like 99% of the people misunderstand how these things work. The fact that you can have the cold side very cold, let's say minus 20 degrees, it doesn't mean that at that condition you can transfer a lot of heat. And that also means that you cannot really use these things in a feasible way to build an air conditioner. Because if you build it as an air conditioner, let's say, then you would like to move a lot of heat from the cold side to the hot side. And that automatically implies that the cooling power is high, therefore the temperature drop between the hot side and the cold side is very low. So if you want to build this into an air conditioner, one device is not enough. Probably you need 10 or 20. And since these are very inefficient, let's say 10, 15, maybe 20% efficiency, you throw out a huge portion of the invested power which comes in this pair of wires in the air, because basically that power which goes in ends up on the hot side, and then you just dissipate it with some cooler. So here, once again, if despite the fact that the cold side can be very cold, it doesn't mean that you move a lot of heat. actually it says that if you have a very cold side, then the transferred heat is very low. So basically there is no cooling, and here also we just have a small surface that is being cooled. So obviously we don't really move heat from the cold side to the hot side, other than the heat which is just used for this tiny volume and the heat caused by the losses. So what we will have here, I have a voltage meter here, or voltmeter. So I measure just the voltage which will be applied on the Peltier cooler. I regulate the power supply with current control. So I set the current to 5, or let's say for example 5 amps, and I let the voltage to be whatever it wants to be. And then I will note down these numbers. And then, for example, in the beginning, I just set the current to 0.5 amps. Then I let the system to run for 5 minutes, let's say. And after 5 minutes, I read all the values and then move to the next step, which is 1 amps. And then I repeat this until reaching 6 amps. And here you see the cold side temperature. This is now pretty much the room temperature. It's what we expect. So then we will see how this develops. And here we have the 8 centimeter cooler. It sucks the air in from this side and the air goes this side. So then the air, the warm air, is basically dissipated in the room. It's a quite large room, so it has enough air to be mixed with this slightly warmer air. I have a thermometer from my earlier project. I will use this as well. And I will just use this to monitor some temperatures, for example, the room temperature according to the thermistor, and the temperature of the air which is coming out here on the hot side. So here I have channel number 2, that will be our room temperature. I just let it sit here. Here I have channel number 3, and I will just squeeze this in between the lamella. And that's all. So channel number 2 on this list is the room temperature, and also the rest of it is just the room temperature. And then channel number 3 is here in between the lamella, so the outlet air temperature. So I turn on the power supply, and that comes in through these wires. And I just slowly increase the current. So this is 0.5 amp. I turn on the cooling. So the hot side is cooled. And now I will just run through this, and when I finish the whole series, I return and explain what happened. So now I am at the last step of the testing, which means that I'm feeding 6 amps through these wires to the Peltier cooler. And you can see that the voltage is rather high, 15.498 volts. The cold side temperature is minus 32.9. And then the air which is coming out here, which is the, let's say, hot air outlet, is 33.3 degrees Celsius. And you can see that the room temperature is around 24.5-ish degrees. So we are, let's say, 9 degrees above the room temperature regarding the hot side air temperature. So you can see that there is a little fog here because of the condensed humidity. You can see it. And basically what is very interesting here is that we went below minus 32 degrees, which is very good, because I will need roughly minus 30 degrees for my upcoming project where I will need these Peltier coolers. So it's good that this Peltier cooler is capable of doing this. It will be interesting to see how much heat I can move. So if I can cool down the volume that I want to cool down quick enough, and I can keep it at that temperature. So that these are still question marks. So now what I will do, I will turn off all the power, and then I just replace the Peltier cooler to this guy here. So the CL-C067, And then we will see if the data sheet or the published data by the sellers is true. So I will just do the same thing. I start at 0.5 amps, measure the cold side temperature like I do it here, and then I move to 1 amps, so 0.5 amps step size, let the system to reach equilibrium, and then note down the values up until 6 amps. So let me prepare the system with this Peltier cooler, and then we will see how it works. So I have installed the other Peltier cooler. So again, this is a 6 ampere unit. According to the pictures on Aliexpress, this should be able to go down to minus 35 degrees Celsius or even below. So we will see about that. And everything is the same setup. So we have the 8 centimeter fan blowing in this direction. We have a probe here measuring the outlet hot air temperature. The air is not hot, but just call it like that. The K-type thermocouple is measuring the cold side. As you can see, the cold side is sealed with a small acrylic plate. And then here we measure the voltage. The current is set by the power supply. I go with 500 milliamps steps up until 6 amps. And then I just monitor the cold side temperature, and then I note down all the parameters that I can measure. The room temperature is still 24.5-ish degrees Celsius. So then let's see how it goes. So I started at 0.5 amps, and you can see that the temperature is already decreasing. So I turn on the fan, which cools the hot side. So you can hear the extra noise now. And now I just do the work, and when the work is done, I get back to you and I report you the results. So here is the final step of this other Peltier cooler. I am running it at 6 amps, and you can see that the voltage is 16 volts, let's say. But the cold side temperature is only minus 25 degrees Celsius. So previously we reached minus 35 easier. But then here it's just minus 25, so there is a 10 degrees difference. So I think that on Aliexpress, where they showed the picture, they cheated. And I think I know how they cheated. Since it's water cooled, I believe that they used a very cold water in the water cooling loop when they took the picture of the cold side temperature. And of course, you can maintain cold temperature in the water cooling loop if you have enough water in your loop, and you can maintain it for a while. So it's just enough to cool down the cold side to sufficient temperatures, let's say minus 35 degrees Celsius, and then you can take the picture. But here it's unfortunately proven that this Peltier cooler is not a big deal. But luckily, the other one, the TEC2 type, is really doing what it is promised on the datasheet and on the Aliexpress selling pages. So if you want to have a large temperature gradient, you should go for the TEC2 Peltier cooler. So now I will shut down this thing, and I will go to my computer and I will show you some data, because I have logged all these down. I have my small notebook here for both temperatures and both voltages and everything. So we will check those and we will compare the, let's say, performance in quotation marks of these two devices. So let's head over to my computer and let's continue the discussion there. Okay, so now we are looking at the first and simplest chart. So as you can see, on the x-axis at the bottom I have the current, and on the y-axis here I have the thermocouple temperature, so the cold side temperature. And then this just reflects the logging that I made. So here at 10 degrees Celsius, around 10 degrees Celsius, I have the first measurement, so that was at half ampere. And you can see that the TEC2 is already colder by a few degrees. And then as I increase the current, you can see that the difference between the two graphs is more and more increasing. And then at the minimum of these graphs, which is roughly at 5 amps, the temperature difference is roughly 10 degrees. Actually, I can check this more precisely. So here at 5 amps, the temperature is roughly minus 33 degrees Celsius for the TEC2, and for the other is minus 25.8. So let's say it's around 7.5 degrees Celsius. So that's the difference, and that's a significant difference. And then while we are still looking at this curve, we can also see that above 5 amps there is, or at 5 amps roughly, there is an inflection point. So if we further increase the current, then the temperature will increase. And this is just an indication that the Joule heating is overpowering the Peltier cooling. So then the device starts to heat itself up, and that is of course detrimental. So then the whole device starts to become warmer, and then we will see it on a further chart that despite the fact that we are pumping more power into the system, the temperature will be worse. So yeah, that's not necessarily good. But immediately we can see it on this chart that the TEC2, the stacked Peltier cooler, performs better in terms of minimum achievable temperature. And then I saved another chart just for fun. At the bottom, again, the x-axis is just the current, and the y-axis is the voltage. And actually what we see in this chart is basically how the resistance of the two devices changes. And it's basically the same. So there is very little discrepancy at higher currents. So then there's a little higher voltage for the CL-C067 unit, but even the curvature of this curve is the same. But this curve doesn't really give us any information. It's just I found it interesting to plot it. And then finally, I think this is also an important and interesting chart. So what we see is the power, so the current times the voltage, which is supplied to the Peltier cooler. And on the left-hand side, y-axis, we see the thermocouple temperature, so the cold side temperature. And as I mentioned just recently, that after a while, the Joule heating overcomes the Peltier cooling, so there is no more cooling effect on the cold side. And what I mean by this is that by increasing the power supplied to the Peltier cooler, we don't notice decreasing temperature on the cold side. The temperature will basically become flat, the temperature logging, as you can see it here. And then if we even further increase the current, then the temperature starts to increase. And that is because more heat is generated than heat is removed from the cold side. So this is also showing that we can basically stop at this value, roughly at when we are at 60 watts, and that is roughly around 5 amps. Because even if we supply 1.5 times more power, like electrical power, to the unit, we don't get better results. So yeah, the, let's say, cutoff value can be at 5 amps roughly. So the conclusion here is that we don't really need to run these devices at their highest rated current. And I showed this in many of my previous Peltier cooler related videos, that they have kind of a sweet spot, and that is where you have the inflection point, because there you maximize the cooling basically. So then basically this is the conclusion of the video. So we don't need to use this Heke Tech thingy. I think there is some kind of cheating with the pictures on Aliexpress and other web shops, so be careful with this Peltier cooler. However, if you want to have low temperatures on the cold side of the Peltier cooler, you should go to the TEC2 unit. And here you don't have to struggle with the stacking, because this Peltier cooler already comes in a stacked format. So you just power one single unit and you don't need to consider two individual units. I have a video where I made stacking, and I achieved quite low temperatures, even below -40 degrees Celsius. But that required me to set up a very careful cooling, and also I had to power the two independent Peltier coolers in a careful way. So yeah, that was not the optimal. And once again, don't be confused by being able to reach very cold temperatures on the cold side. That doesn't mean that you can remove a lot of heat. It just means that you used the temperature gradient part of the trade-off. So what I mean here is there is a trade-off between the lowest achievable temperature on the cold side and the amount of heat that can be removed by the Peltier cooler. So then either you can cool something, or you can make something very cold, but you cannot do the same at the same time. So that's what we have. So I conclude the video here. And if you want to have some more information, go to my website. Link is in the description. I put some extra things there. I wrote an article, and you can also find the relevant parts that I used in this experiment. So if you want to buy the same parts, you can use my affiliate links, so that supports me. And if you want to support me even more, please consider supporting me on Patreon. I have a Patreon site, and you can follow me there and support me there. So that helps me to make these kind of videos. And then the spin-off of this project will also show up on my channel quite soon, within 1 or 2 weeks. And that will be a very interesting project. So please don't forget to subscribe my channel and stay tuned. And you will get some hopefully more interesting content. So I hope that this experiment and video was useful to you, and I see you in the next video.